Today in class we learned about arithmetic sequences. That's A-R-I-T-H-M-E-T-I-C, sequences. Now again, we're going to learn about other kinds of sequences, specifically geometric sequences. We're going to learn about those later on. Arithmetic sequences are sequences where each new term is found by adding or subtracting a number to the previous term. So, for example, let's say we have 3, 5, 7, 9, ... Every new value, every new number in the sequence is found by adding 2. So 3 plus 2 is 5, plus 2 is 7, plus 2 is 9. Or we could subtract a number. So my common difference here is going to be 2. I could also subtract a number. So I could start with 3 and I could subtract 2. That would be 3 minus 2 is 1, minus 2 is negative 1, negative 3, ... In that case, my common difference would be negative 2. So I'm either adding a positive or a negative number. You could also think of this as adding a number or subtracting a number. But my common difference is always an integer. So if I'm adding, it's positive 2. If I'm subtracting, it's negative. So arithmetic sequences are linear functions. Well, they're the way you guys used to solve these, you would find a linear function for them. So we really have 3 different formulas that we could have for an arithmetic sequence. We have a function formula, which is the formula y'all used to find last year. So for example, let's look at our 3, 5, 7, 9 example. Okay, so what you would do last year is you would take that 3, 5, 7, 9 sequence and you would make an X. Well, y'all would make a whole table here. You'd put 1, 2, 3, 4. Then you do the Y values would be the values of the sequence. So this means the first number in the sequence is 3, the second number is 5. And then we'd start actually, plus 2, that's a 2 by the way. And this is plus 1, plus 1, plus 1. You'd find your delta Y over delta X, which is 2 over 1, which is 2. So that means 2x plus something equals y. 2 times 1 plus, so that's 2 plus what equals 3? 1. Now we try it again. 2 times 2 plus 1 equals 5. So my function formula would be y equals 2x plus 1. So that's what you're used to doing. You're used to finding a function. And I may be calling it wrong by calling it the function formula, but whatevs. Okay? That's what I'm calling it because this is a formula in function notation. And this is the process that you guys have done up until now. We're going to start using 2 other formulas. So the first one we're going to do is the recursion formula. That's not even spelled right. It's not recursion. Recursion formula. Okay, now the recursion formula is a little unusual looking. It looks like this. T sub n equals T sub n minus 1 plus D. Okay, D is my common difference. And that is what do I add or subtract to each row. Okay, so in this sequence, my 3, 5, 7, 9 sequence, okay, my common difference is 2. So to write my recursion formula, I'm simply going to replace that D with a 2. Okay, and what this formula means is, this formula is saying I'm going to take, to find this, the term I want, I'm going to look at the one before it and add 2. So if I was trying to find term 4, I'd take the one before it, which is 4 minus 1, and I'd add to it. So T4, that's T3, so T4 equals T3, which is 7, plus 2, which is 9, exactly what I have in my sequence. Okay, so that's what we're looking at when we talk about our recursion formula. I can use the recursion formula to find the next number in the sequence. If they said find T500, nobody's going to do this 500 times. I mean, unless you've just literally got nothing but time on your hands and, quite frankly, you're bored. Okay, because and you don't like yourself. I don't know why you would do this otherwise. Okay, the last formula that we have is the one that we would use if we needed T500, and it's called the explicit formula. Now this one really looks nuts, but it's actually very intuitive once you think about it. Here's what that formula looks like. It's T sub n equals T1 plus D times n minus 1. Now this is a strange formula to wrap your head around, so let's unpack it here a little bit. Okay, well first I want to write the sequence down. 3, 5, 7, 9, just so we have it with us. Okay, so this number right here is the term I'm looking for, and I didn't really talk about that over here, but Tn is the one I'm looking for, n minus 1 is the one before it. Over here, Tn is the one I want. So this is what I want. This is term 1, so the first number in the sequence. This is my common difference, and this is n minus 1. What this actually tells me is the number of hops. Okay, so if I look at this equation, this is a 1 by the way, okay, I need to know, anytime they want me to write an explicit formula, I need to know what T1 is, and I need to know what D is. Okay, in this case, D is 2, because I add 2 to each term to get to the next term. The first term in my sequence is 3. So, if I want to get from 3 to 9, what do I have to add? I have to add 6, which is 2 plus 2 plus 2. So to get from the first term to the fourth term, I have to add my difference 3 times, which is 1 less than my term number. So what this is saying is, the number I want, I'm going to start with the first term, and I'm going to add my difference. I'm going to add my difference 1 less than the term number. And the reason for that is because it takes me to get from the first term to the fourth term, it takes me 1, 2, 3 hops. If I want to get from the first to the 20th term, I'm going to hop 19 times. So I'll take that difference and multiply it by 19. If I want to get to the 700th term, I only got to hop 699 times, so I'll take that difference times 699. Okay? So, if whatever number they ask me for, I just substitute in. So let's say they want T7, okay? Because we can verify that that's right. I'm going to take 3 plus 2 times 7 minus 1. That's 2 times 6. It's 3 plus 12, which is 15. So if I continue this, I have 11, 12, 13, 15, 1, 2, 3, 4, 5, 6, 7. Boom, there I am. I got the same answer using my explicit formula as I did using just by continuing out my sequence. Now, the thing is, I think once you understand this formula, I think this formula is a lot easier than doing this process. But we have to know all 3 of them. You've practiced this a lot. The recursion formula is kind of new, but it makes sense. It's what you do anyway. If I want to find the next term, if I want to find term 2, I look at term 1 and I add 2 to it. If I want to find term 3, I go back to term 2 and I add 2 to it. That's what this is saying. It's just we're having to write it in math for the first time. This one, same thing. If you understand what the sequence means, it's pretty easy. I'm going to take the first term. I'm going to add my common difference 1 less than the term number I'm looking for because I have to hop 1 less to get to it. Okay? Let's try another example. Let's try a different one. Let's try this one. Here's the sequence we're going to try. Negative 15, negative 7, 1, 9, dot, dot, dot. So we're going to start. Anytime they ask me to find anything about these, the first thing I always find is T1 and I find D. Well, my first term is obvious. It's negative 15. It's the first thing I see there. My common difference, plus 8, plus 8, plus 8. So my common difference is 8. Now, if I was subtracting 8, I would do minus 8 instead of plus 8. Okay? So, if I want to find my recursion formula, which I can use, and I'm not going to go over how to find the function, how to find the linear function, because you guys have done that a ton. I don't need to spend time on that. But the new stuff is the recursion and the explicit formula. So my recursion formula is T sub n equals T sub n minus 1 plus D, which is 8. Okay? And again, The reason I have to know these is because these are the only two things I'm going to plug into a formula, because that's what I'm looking for. If they give me a formula, I want to be able to use this formula on any term. I want the most generic formula possible. Another thing I want to briefly mention, which I mentioned in class, you don't do math on these. These are like variables. T sub n, anytime you have a subscript, it's telling you which one. So like, on our calculators we have y1 and y2. That's why they're subscripts. This is the first equation. This is the second equation. Now, if they gave you an exponent, they're telling you how many times to multiply. So this is an exponent. If it's a superscript, which is above, it's an exponent. If it's a subscript, it's telling you which one you're looking for. So 3 squared would be 9. 4 to the third would be, I think, 64 if I'm wrong. I'm sorry. Okay? So there's my recursion formula. Remember, these need to be written as subscripts, and they need to be written small, because if you write them wrong, you're going to think you need to do math with them, and you don't. This is the one I'm looking for. This is the one before it. Okay? So if they ask me to find the next 3, okay, I would say, well, 9 plus 8 is 17. 17 plus 8 is 25. 25 plus 8 is 33. Is that right? I think it's right. If it's not, again, I'm sorry. I'm kind of doing this off the top of my brain. Okay, the next one, let's talk about the explicit formula. Okay, and this does not mean like parental advisory explicit lyrics. It means a very detailed, specific formula. Okay, so my explicit formula uses T1 and D. Okay, so it's T sub n equals term 1, which is negative 15, plus my common difference, which is, 8 times n minus 1. Okay, now if they ask me to find, let's say they ask me to find the 7th value, because I know the 7th value because I've already found it. So let's say they want me to find T7. Okay, well then I would say T7 equals negative 15 plus 8 times 7 minus 1. Okay, so that's negative 15 plus 8 times 6, negative 15 plus 48, which I'm going to use my calculator for y'all. Negative 15 plus 48 is 33, which is exactly what we got for term 7. Okay? So this is how we use these formulas. I feel like I should do one more where we get smaller, but I don't have one ready right now. Actually, I'll do the one that we did in class. I'll do the one that was the last example in our notes. 19, 16, 13, 10. Now this one is getting smaller. Okay, so again, I find T1 and I find D. Well, term 1 is really obvious. It's 19. My common difference is minus 3. Okay? So now, when I find my recursion, I'm going to have T sub n equals T sub n minus 1 minus 3. You could put plus negative 3, so if you put T sub n equals T sub n minus 1 plus negative 3, that is perfectly fine. But this is how you're going to see the final answer most often. So I would get used to writing it this way. Okay? My next 3 terms, if I use my recursion formula, my next 3 terms are going to be 7, 4, 1. It's going to keep on going. So again, if I look at my explicit formula, my explicit formula says T sub n equals term 1 minus 3 times n minus 1. Okay, again, 19 minus 3 for however many hops I subtract 3. Okay, so let's say, again, let's try term 7 because we know what it is. Term 7 is 19 minus 3 times 7 minus 1. That's 19 minus 3 times 6, which is 19 minus 18. Term 7 should be 1, which it is. Okay?